Hello, everybody. We are working on Chapter 34 tonight. We've gone through the painstaking process of making sure that everybody has a database account, created a database, fed all their database information in to populate all the tables. And now as we begin to actually work on the Chapter 34 stuff, I want to go through a little bit of the concepts of relational database systems before we dig into coding for them. The one thing that's kind of interesting is Java, like many programming languages, do provide special connection scripts for allowing you to take whatever IDE you're using, whether it's something as primitive as JGrasp or something as fancy as Eclipse, NetBeans, or IntelliJ, and by using that separate connector file allows you to interface with various types of databases. The one that we use here at Gateway, of course, at least for the web program, is the MySQL database system, but database connections to other platforms are entirely possible given the right connector. So if you were connecting to SQL Server or Oracle or you name it, there are connectors out there that you can add to whatever program that you're running or to your IDE and then make an interface to those databases. I want you also to keep in mind that what's one real critical thing here is that what we're about to code through is a very real world type of example of how real Java programmers interface with remote databases for applications. And this is how professional work is done, which is why we feel real strongly here at Gateway that you guys need to learn how to do this, not to work with a local database rather than a remote one. But long story short, the language that we use to work a database, most major database systems, by the way, use this, is a language called SQL, or some people will call it SQL. It is an acronym for Structured Query Language. And it is not a programming language. And some of you, I think, have already realized that, or you're actively learning it. A query language is a language that's designed to basically allow you to ask a question of a system and get a response depending on how you structured it. There are some commonalities to programming, but it's not exactly programming, which many of you have already learned. Do you need to be an expert at SQL or databases in order to code for a database? And the answer to that is absolutely not, but it certainly doesn't hurt. I will tell you that database skills are highly, highly employable, by the way. People who run databases and code for databases can make significant amounts of money doing so. And I had a family in-law. One of my cousins married an IT guy, very much like myself, who has made an entire career of doing contract work for databases, and he's never gone hungry a day in his life. And he shared a little adage with me once. He said, Ty, I learned databases, and somebody told me when I learned to do it, he goes, you'll never be hungry if you learn databases. And the truth is, if you know how to code, it's really kind of the same thing. The only thing it's going to hold you back is yourself, because the work is out there. All right. So let's talk about what a database is and what we're about to do. And so whenever we're sitting down at a computer and using it, we take for granted a lot of times what's happening behind the scenes of any application that we're running. So here's us as users using an application, and we're interfacing with a program. That program, most programs, by the way, typically have a database on the back end to store the information and and allow the application to do things that it otherwise could not do. The one thing that you realize often when you run an application, especially when you learn what a variable is, as soon as you turn a program off, what happens to the variables? They disappear. They're loaded out of memory and they're gone. So if you want to retain any of the information in an application, either a database or a text file are the two structures you typically go to store your information so that when you launch that application again, you can bring it back. And so very, very often application programs will interface with the database. However, as you guys may have learned in your database class, the database itself is not the way you interface with the database. There's always a layer in between called the database management system. For us, using Apollo and MySQL databases, we can use one of several different tools to interface with the database. One of them is the MySQL monitor program that we used at the command line to create the database in the first place. The other one would be phpMyAdmin, which is a web-based tool. And then you can use the tool that Oracle has created, who is also the creator of MySQL, by the way, also the creator of Java, which is why they work well together, called MySQL Workbench, which is a free download. All the software is available for free. And then those tools actually act as the layer that allow us to interface with the database. Now, what we're going to do as we code is we are going to eliminate this piece and use the connector file for Java that basically replaces this component and allows our application to talk directly to the database. And that's pretty important to know. All right. So we talk about the different types of databases here. They mention a few, significant one by name. So the MySQL is on the list. Oracle, of course, has a professional version of their database, which is really what made Oracle what it is. Frankly, their database system is huge. There's IBM's DB2. So if you guys are software students, that would be a platform you would learn in the software program. SQL Server, of course, is the big Microsoft product, and there's also Sybase. Another thing that's happened in recent years is we now have a number of different database systems that are called NoSQL databases. They operate a little bit differently. For those of you taking the Web Programming 2 class, we do cover NoSQL databases in that class, typically with MongoDB. So if you're taking that class with Christian right now, you will be learning about that system. And that also has connector files for programming languages too. Now, the interesting thing is as you start to work with your application, a database management system can actually interface with multiple databases at the same time using the same system. And your application program, unbeknownst to you, might be communicating with not one database, but actually many in the background. In fact, that's actually much more common than you would think, especially true on web-based applications, by the way. When we start to think about what a database is, we usually think with the most fundamental structure being what we call a flat file or a table. And you can think of it sort of like an Excel spreadsheet, but it's basically a text-based structure that is set up with fields that hold certain types of data. So like you see at the top here of this table, I have several different fields. And then if you look at the columns below each field, they'll have certain types of information in them. It looks like the course ID is a numeric field. This looks like a text field, text, and numeric, right? And so we have data types that are associated with the columns. And this structure as a whole is called a table. Now, a relational database system will often have many tables. So the first table that we looked at was looks like a course table. So this is a list of courses at a school. There's a course ID, subject ID, a course number, and a title and number of credits. If you look at some of the other tables that are part of maybe this education database, seemingly, there's a table that holds the student information. So here we see their social security number. And yes, in the old days, we used to use that as everybody's ID number, by the way. Horrible idea, but that's what they did. And then you see the columns, first name, middle initial, last name, phone, birth date, etc. And then you see this other table that they have in the database called the enrollment table. So if you were a student with this ID number, you enrolled in that course, and this is the date you registered, and this is the day you got, or the grade you got. And notice that we don't include all of the students' information in this table or all of the course information here. What we're really doing is we're forming what we call relationships between the tables. So the course ID in the course table is equivalent to the course ID in the enrollment table. And those links or those relationships are why we call a database a relational database, because we get multiple tables that work together to form the database. All right. Now, that's a really quick overview of how databases work. Super, super quick. In your database class, and those of you that are taking it currently, you will have learned all those things. And by this point in the semester, you're getting deeper into things like inner joins and probably
the keys or
Yeah, primary keys. Thank you. Joins and all those kind of fun things. Now, in terms of the language that we use to query a database, SQL is the language, and most major database systems uh, read SQL as their primary query language. Some of them will have slight alterations, which I've been discovering. Like SQL Server has some commands that are a little bit different than the ones that MySQL uses. But for the most part, the command that works for MySQL database will also work for SQL Server, Oracle, DB2, Sybase, Postgres, et cetera, et cetera. Many of them share this language. Now, there is a whole section at the back of our book in the supplements and online on the companion website, as it indicates here, where they actually have tutorials for all the major database systems, by the way. So if you want to really, dig into the author's stuff, go for it. Otherwise, just rely on your database class. I'm not here to teach you how to write SQL. All the SQL code that you will need will generally be provided. And if not, we will help you code through it. Okay, so that's not the important part here, is to learn that language. We went through this process of creating all of the accounts. We created the database. And then the last command that we just ran, in fact, we did it again just before we started this video, is we ran the source file that helped us populate the database with information so that we wouldn't have to manually build it with a series of commands. All the commands were built in. You just ran the file. Boom, you have a whole database, all the tables, all the information is inserted, ready for you to work with. So that's what we've accomplished thus far. All right. They go through the whole process here of talking about how to create tables, drop tables, and really sort of what they're doing here is kind of giving you this whole primer on SQL. If you want to do a little bit of a refresher, so I know I have at least one person here in the class that's already finished this, and two people in the class that have already finished this. If you guys don't remember all your commands, this little section might be helpful for reviewing what some of the key commands are. The ones that are most important typically are the ones where you can simply select, the simple query, select from, and then maybe indicate a condition. And most of what we're going to do is either select a record or we're going to insert a record or update a record from the database. We will walk through all of that sequentially. So they kind of go through this whole process of basically showing you the whole language. And I'm not trying to fly through this, but if you guys need a refresher, feel free, to go through that in detail. Where we want to focus our attention now is on this section of the chapter, which is section number 4 on Jdbc. Now, whenever we create, Java applications that talk to a database, we use a special connector file. And if you notice here, this is actually considered an API. It's an application programming interface, by the way. That's what the acronym means. In short, what that does for us is it allows us to connect to the database. It interprets our SQL command and converts it over to what the database can read and actually do something with. And so without that piece, we will not be able to talk to any program. So the Java, the JDBC API is critical for any application that is connecting to any sort of a database system. And then on top of it, you will need the specific JDBC driver that matches the database you're connecting to. Here's just an example of 3 popular ones. Yes, there are connectors for SQL Server as well. So if you were able to create a SQL Server that was out on the internet and accessible either behind a firewall or not, you could write applications that talk to that database. Or you can write to ones that are local. What we're going to use is this approach here, the very first branch of this. But those techniques very simply can translate to other database systems, provided you just have that right driver file. For the exercise in this unit, I have a driver file for MySQL attached right to the assignment. And I will show you guys how to use that as we get there. Right now, we're going to start looking at some of the Java constructs that we're going to need to be able to write the application. And you'll see the Java commands will be in blue here. So these are real common ones: the driver, connection, statement, and result set. The driver, of course, will load the driver for us. The connection will indicate how the connection happens. The statement will hold the SQL commands that we're sending, and the result set will return to our application, or will hold what is returned from the database so that our application can utilize it to do whatever it does. All right. And so that driver and the connection can allow you to actually do these things multiple times. And yes, you can talk to multiple databases simultaneously and get multiple connections and result sets all simultaneously if you wanted to go that deep. All right. Now, in terms of how we accomplish this, so this is where I'm going to kind of go a little bit quick, and then we'll see it in actual code. We have to first load the drivers. So you are going to see that we're going to set up these libraries here and call on the driver class. They have a couple of links here. I want you to notice that these connector files do change versions over time. In some cases, it doesn't really matter which version you use, and I'm sure the one I have attached to the assignment is probably a little bit old, but I assure you it works, which is why I use that one, by the way. If you want to get the most latest, greatest ones, you can go out to the Oracle website, or you can go to, or just Google it, MySQL connector for Java, and you will find it on the internet. It's a free download. Oracle will want you to log in and register, though. What do the drivers look like? Well, depending on what type of work you're doing, this is what the driver files will look like. So this would be the code that you would add in. In many cases, you might have to, if you're working on the command line, there's some special stipulations here. So you have to let your command line know that where that connector is. Not a problem if we're using Eclipse, by the way. Eclipse will handle all of that for us. All right. I want to look at this little thing here. Java does support automatic driver discovery to a point, but it's usually better to know where the stuff is and which connector you're using in advance. If you don't, it will, depending on how you approach the application, that's kind of a caveat, it will help you to some degree. Some IDEs are better than others. Eclipse sits somewhere kind of in the middle of convenience and power, so keep that in mind. We will establish connections. So you will see, verbiage like this. This is the verbiage that we're going to use. And you can notice that it will be prefaced by Jdbc. That's the driver. MySQL is the connector. And notice how it looks kind of like HTTP address, right? Like a web address. And guess what you'll put here? You'll actually put Apollo server name in this place, and then the name of your database, and we'll get to that too. All right. Then finally, as you kind of get the connection going, you're also going to throw in a connector that's going to kind of look like this. So this is actually a whole Java statement here, folks. And what we're going to do is we're going to add code that's going to connect us up to the database, and then we're going to feed it our username and password. Yes, they go in plain text, by the way. Now, you got to keep in mind that once a Java file is compiled, you cannot see what the usernames and password are. But when you write it into the code, you can. So that's kind of critical. And this is very common because you want to control access to the database, but at the same time, you want to make it easy to code for as well. But yes, it does go in plain text. So please be aware of that if you're sharing screens or anything. Once we have all those pieces in place, I think we're ready to start creating statements. So you create an object that will hold the statement. Then you start creating the statements, and what you do is you write SQL statements inside of a Java method, just the same way you would write it in any other platform. And so whether you're creating a table, pulling back information, or inserting or updating or deleting or dropping a table, or whatever the command is, it can all be done inside one of these statements. Most of the time when you're doing this stuff, you're also going to be expecting something to come back from the database, like some sort of result that you can see and then put on the screen. So if you do like a search for something, you want to get the whole record back. And so that requires this structure called a result set. And then, if the result set brings back more than one record, sometimes we write loops that will loop through all the results and display all of them on the screen. So maybe you do a search, how many people are named Bob who are students, right? There might be 50 of them, right? And so if there was just one result would come back. If not, a whole bunch of them would come back. All right, so what we're going to work on right now is we're going to actually recreate this very simple little program here. And we're going to create it line by line. So if you guys have your book handy, you can throw this over on the second screen. That's what I'm going to do. And we're going to just code. We're going to copy what's here, drop in our own information, and then we will be able to connect to the database. I'm going to pause the recording here for just a minute. All right. Hopefully everybody's got their Eclipse IDE up and running. I am going to go ahead and create a new project to do this work, by the way. So this is chapter 34. So I'm just going to come up here, create a new Java project, and call it chapter 34. And then I'm going to go ahead and click finish. All right. Now I'm going to go to the source folder, right click like we normally do, and create a new class file. Now, I'm going to call this, just like they did in the example, simple Jdbc. And remember, the goal of this is just to get it to work. That's the whole bottom line.
Are you supposed to be seeing your screen?
You are supposed to be seeing my screen. Thank you for saying something. I appreciate that. So here's my screen. By the way, your faces, those of you with cameras on, your faces were just recorded into the video, by the way. I just want to let you know that. So hopefully you weren't making too many silly faces in the process, but I appreciate you letting me know, Jay. I'm going to go ahead and create a public static void main here because we will need it. And here's the beginning of our program. I am going to bounce back to the browser now, where I do have that open somewhere right here. And I'm going to move this over to my second screen and just basically replicate this bit by bit. So what I'm typing into Eclipse comes from that file. So follow along if you can. So let's begin with a couple of really basic things. Normally I don't type my import statements first, but in this case I'm going to. And I'm just going to add the java.sql library in its entirety. And you notice the asterisk in the last position. That allows me to invoke any of the, the database API tools for SQL. All right. We have our public class declaration. We have our public static void main. And normally, if I was to create something like this, I would be really cautious about also throwing in this statement. And we haven't, I guess, formally learned about this in this class. Did you guys cover exception handling in your Java 1 class?
Only a very little bit, yeah.
A little bit, yeah.
And I'll tell you the reason why you don't cover it a lot in the Java 1 class. The typical reason for that is, you don't get deep enough into the materials, for one thing. And normally, this is a byproduct. Whenever you're writing a program where you're interfacing with any sort of input or outputs, if you're relying on a file or a database connection or anything like that, like some external resource, we add these statements to methods in order to make sure that we don't have errors that will terminate the program. So for example, the reason we're throwing a SQL exception is if I can't connect to the database, I don't want the application to blow up and stop working. I might put a message on the screen saying, hey, I can't connect to the database, come back later, something like that. But this is an important thing to add. And if you don't add these statements, what will happen is your other methods will start to underline and they'll say, hey, this won't compile because you don't have any exception handling here. This is going to crash. There are other ways around this. Try catch statements are one of those ways around it. But this is considered required, these statements, when you're doing database connections. And if you don't add them, Eclipse will red underline, and you can usually right click and it will add them automatically. But I know this in advance, so I'm just doing it. The one thing that the book does is it does put in comments, and I think it's not a bad idea to do this the first time around so you know what's happening. And this first little method is to load the driver. We're going to copy exactly what's in the book. We're going to type in class for name, and then we're going to put in the driver that we're going to use, which is going to be exactly com.mysql.jdbc driver with a capital D. And you know, that's another one of those strange things. If you use it enough, you actually like memorize that. and I'm kind of embarrassed to say, yeah, I've memorized that. Now we're going to do something we haven't done in a while, which is we're going to do a plain old system out print line here, folks. How do you like that for revisiting the past? But we're going to start using our system out print lines not to run our applications from a console. That's not the point here, but to use the console output for our own benefit, right? So these will be messages the users will never see, but we'll see in the console. So when the driver loads, we'll get a message that says driver loaded. And then we'll add messages like this often because they're very useful when you're like building an application to see if stuff is working, and the user never has to see it. Right, so that's the first piece. Second piece is to actually establish the connection to the database. All right, for this we will invoke the connection class. So this is going to require a library, control space to add it, and notice how we can pull it in here. So we're going to pull in Java SQL. And actually the reason it's underlining red is that the library is already up there, right? Duh, okay. The reason it's underlying red is because I haven't finished what I'm doing, but I'm just going to call it connection because that's my normal go-to. It looks like it's the author's normal go-to as well. And then I'm also going to invoke driver manager and the get connection method. And then it's inside here that we're going to put all the very specific things that we need to actually form the connection, like we talked about just a few minutes ago. So here we're going to type JDBC with a colon followed by mysql and then a colon / like a URL. And in the book, the example says localhost / Java book. Now, if you were running a local web server, you could type localhost and it would basically loop back to your own web server and MySQL account and connect. However, we're actually connecting to a live server. So here you actually put in the name of the server, just like you do for your web pages and your FTP and all that stuff. So you're going to put in apollo.gtc.edu. And really what this is telling us is this is the protocol that we're connecting to. We're connecting to the MySQL server on this domain and machine. We're going to continue the statement by also adding the name of our database. Now, for each one of us, this will be a different entry, right? You're going to start with your username. For me, it's that one, very fancy. And then we're going to append to it the name of the database as we decided. So for you, the A's will be replaced with whatever your username is. At the end of that statement, you're going to put in your closing double quotes, a comma, because now we're going to add our username, another comma, and now our password, yes, in plain text. And now you guys know what my password is. The most insecure password out there, by the way. But yeah, I do that on purpose because you know what? Hey, if you guys want to attach it to my database, hey, go ahead. You know,
Was it 1, 2, 3, 4, 5?
Yeah, it could be 1, 2, 3, 4, 5. That would be almost as insecure.
Last question. Is that an underscore between the A's and Java book?
That's a good question.
Okay, awesome. I couldn't see it very well. I was like, wait.
Yeah, you know what? That kind of prompts me to, why don't I zoom in just a tad here? And you know, this is also one of the reasons why some people will write these connections like this. They just move the parentheses down to the next line, and that's absolutely fine. That will work just fine. In fact, it looks like the book example does exactly that. Now, if we establish the connection to the database, we're once again going to do a system out message. We're going to write to the console. And this time we'll just say something that relates to this, we'll say database connected. So we'll see that. Okay, driver loaded, database connected, check, checking stuff off the list there. Next, we will create a SQL statement that we're going to feed to the server. Now, in this case, we're setting up the container for it first. All right, and this one is pretty simple. We're going to call upon the statement class, and let's just call it statement, all lowercase. And then we're going to pull the connection that we already have. And then from there, we're going to invoke this method called create statement with a semicolon. Now, normally, we would actually type, some stuff in here, depending on how you're setting this up. However, we're going to do this in a separate step, and I always consider this a better practice, by the way. Here's where we're going to actually execute the statement. So I'm going to type execute the statement. This is where we pull in our result set. So we're going to type in that class, result set, and I'll just follow the naming convention I'm using, just doing it lowercase. And now we're pulling the statement, and then we're going to invoke the method called execute query, which basically is going to be a string. So what's going to sit inside here where it says arg0 is the exact SQL command that we want to send to the database. Now what I'm going to do is, this is going to get a little long, so I'm moving down to the next line, and then I'm going to put in my double quote and start. So it says select first name, comma, MI for middle initial, last name. So just first, middle, and last name from which table? The student table. With what criteria? Where last name, in the book, they're going to another line. I'm not doing that here, by the way, folks, because I think I can make it fit. Equals, and this is where you got to be particularly careful, because now we're mixing single and double quotes. And I want to kind of point out something that's kind of interesting. I'm going to bring the book back over and then compare what the author just did there with what I just did. So I'm just going to do a little scrolling here so you can see both. So if you look at his SQL statement and mine, he went to another line, and so he had to close his double quotes here. See that? And then he concatenated and then had to reopen them to continue the statement. Now, I put mine all on one line. Hey, it fits. I'm doing it, right? And I still have to be mindful of the fact that since the database is looking for criteria, we have to alternate between our double quotes and single quotes. I'm usually double quotes on the outside, single quotes on the inside kind of person, but you can actually flip that. The one spot where you're most likely to make a mistake when you're doing this database stuff is the single and double quotes in these SQL statements. That's the thing that will break it most often, by the way. All right. So that's always a thing to look at, is what your SQL statement actually says. All right, I'm going to move this back over. And then this is enough to execute the query. So once you send the command to the database and it executes it, then you have to get into the situation where you need to pull the information back and you need somewhere for it to go. So it's kind of like a result set is really kind of the same as like saying like a return statement from a method. You're expecting something to come back, so you got to have a way to look at that. We're going to actually, and what did the author say here? Iterate through the result and print the student names. All right. Can we talk about that word iterate? What the heck does that mean?
Loop through.
Yeah, and more importantly, Javier, that is very correct, because it's always referring to loops. Because with loops, we expect what? That they're going to go over and over again. And so when we run a loop, we reiterate, right? We do it over and over again. If we go through it once, it's an iteration. Single iterate is a single time through the loop. And so what they're saying is we're going to step through the loop as many times as is needed and pull back the information. That's a good vocabulary word, by the way. Makes you sound smart. All right, so now we're going to pull back our result set, and then we're going to run this method called next. So what that basically does is, as long as there's another result coming back from the table, it will keep going. And as soon as there's nothing else, it will stop. So that will happen automatically. Now you can put your curly brackets here, but there's really only one statement inside the while loop, so that really is not necessary. And now what we're going to do is we're just going to do a system out print line. And inside that print line, we're going to type the commands as we see in the book. So this is how they begin. First, they're going to pull back the result set. And we're going to get the string from position 1. The first column is what that refers to. And you see how Eclipse kind of prompted us. And so what they're saying is this is the first column index. And let's talk about that for a second. So which column actually is that in the table? The first column? No, it's actually the second column, right? Because if you were to look at that table, like if you were to scroll up in the book, the first column is actually the student ID number. And in fact, here's something that we might want to try doing here is if you're not already logged in, you might want to go to phpMyAdmin. Remember, a VPN connection has to be active right now. So, for those of you who have got VPN working, I'm just verifying here that my VPN is active and connected to Gateway. Otherwise, none of this will work, by the way. And now we want to look at apollo.gtc.edu and phpMyAdmin. Log in using your username and password. All right. And the reason I'm doing this is I want to see what I'm connecting to on the one hand, and I also want to see what's in there. Okay, so the table that I'm connecting to, if I look back at my code, is the student table, right? And I am connecting to the Java book, but this is the table I'm going to. So in phpMyAdmin, I clicked on Java book. Now I will find the student table, and aha, well, I got some issues here because first of all, I don't have a student table. You guys noticing this? Yeah, there's no student table, so that's going to cause a problem right there. But I do see that I do have a few entries here, and coincidentally, I do have a couple of people with the last names of Smith, which is what we're looking for. Isn't that convenient? However, this name is different than the name that I have in my code. So that's pretty significant, right? So if I tried to run this, even if I got everything perfect, this would fail because it's not finding the right database. So what I can do in this position is I can either change it here to match, which is what I'm going to do, or if I wanted, and that would be probably not something usually in a web developer's purview unless you created the database. So if you have a DBA that's running this database, look, hey, what are you doing changing my database, right? So you could also change the name of the table, but I would really caution you against doing that. I do notice I have a second one here that's empty, by the way, but we're going to use the first one, making special note that it's student 1. And I want you guys to notice what's happening here. As I click on any one of these tables, it pulls back information. But do you notice how it's pulling it back? It's actually writing a query. So it's like pulling back everything from whatever table we designate. So that's one of the cool things about phpMyAdmin is as you click on stuff, it's actually writing query statements to get the stuff on the screen. And it's showing you which query statement it put together to get what you see on the screen. And I think that's kind of cool. The other thing that's kind of fun about this interface, by the way, is you can actually, if you wanted, like I don't like that query statement, I can go in there and edit it and do stuff, and notice all the commands are already saved there. That's not really our main concern right now. What we want to know is what's in this table. Do the names match up with my code? They do now. And then what's in the table? What should I expect to get back? What I should get back is John F. Smith. And I'm noticing a couple of issues here. All right, so I'm noticing, first of all, this thing is not matching up. I don't have a first name, middle initial, or last name field. So what they've done is they've changed the database from addition to addition. And so I can't pull back all those fields. What field should I pull back? Yeah, the answer is full name. So that's what I'm going to do. But this is going to create a little bit of a problem, isn't it? Because now I can't search for Smith by looking for that exact criteria. We would have to change our query. So here's what I'm going to do. I'm actually going to go ahead and create a new table, if you will. And I'm looking at the student table number 2 and thinking, this might not be a bad idea to maybe just look at this table as maybe the table I want to use. And I'm noticing, well, this one's got different stuff in here, so I can see the structure of it, right? But I'm not really happy with the fact that they changed this on me, because normally this is like a really easy demonstration. So let's change what we're doing. And so right now I'm going to look at maybe like the staff table. Okay, here we have last name, first name, and middle initial. That's pretty good. That works out. So I'm instead going to direct my query to the staff table. And see, this is one of the reasons why, as a developer, right, you want to have access to the database and be able to look at it. Because how are you going to connect to something where you can't see what you're connecting to? All right, so I'm glad I looked, because otherwise I'd be doing this and I'm like, I don't know why it doesn't work. And here is an example. Unfortunately, there is somebody with a last name of Smith in here, and then somebody, obviously this is one of my nonsense entries, but you can see the staff table does have that information. So we're going to attach to the staff table instead. So I hope you guys are all catching that. So let's go back to Eclipse and let's switch this to say staff. The last name field, does it match up? And now these field names all have to match exactly. All that stuff has to match. And so let's just check. Camel case, camel case, camel case. Staff is with a capital S. I think we're okay. All right, back to the code. So I think we're okay there. Now let's finish off this statement. So we're getting back our result set, and now we're going to append to this. Notice the author put in a /t. What does this do? It puts in a tab stop, folks. So that's a way to get your text output to display a tab. So in other words, we're going to put something on the screen from column 1. Column 1 is going to be, in this table, last name. This is column 0. This is column 1, column 2, column 3. That's how it works. All right, so from there, we're now going to get a result set. Oops. And now we're going to pull in column 2. And then we're just going to follow this pattern. Now I'm going to move down to the next line because I'm kind of running out of space here. So I'm going to put my concatenate mark there. And now I'm going to put in another tab stop. And then I'm going to concatenate to it basically the same command again, but we're just going to pull back column 3. So I'm just going to copy this. It's easier than retyping it. And we're going to pull back column 3. All right. The last thing that we do, and this is a thing that is required whenever you're working with a database, but really the truth is whenever you're working with any sort of an external resource, whether it's a database or a text file, it could be that too. You need to, once you open up a file and you manipulate it, you need to close the connection in order to be able to free up the resource so somebody else can work with it. And in databases, that's particularly important. more so than text files, but I'm going to argue it's just as important with text files too. And so that command is just simply connection.close. All right, so now if we take a look at this, here is the entirety of the program. And I'm going to do a Control S to save, but there's one piece that we have not included here in our code. So if you're looking for all the code, there it is. And that is the connector file. So if I need to direct you guys back to our unit folder for this one. So go to the unit 4 folder, find the assignment listing, wherever the heck that is, there it is. And you'll see this file right here, the MySQL connector Java file. I want you to click on that and download it to your machine. You will get a warning. You see, I know it's safe, so I'm going to go ahead and say keep, and it will download. It's fairly small. It's about a meg in size. All right, and it's of a file typed, and I'm going to pull this up in the folder. I just want to show you this, with a jar extension. Do you guys remember what a .jar extension is in Java? All right, since you're not all rushing in to answer, the answer to that is it stands for Java archive file. This is Java's version of a zip file, basically. And so this is a one file that can be decompressed to extract a bunch of resources. Now, all you need to do at this point is just have this handy. You can leave it in your downloads folder if you wish, which is what I'm doing. And now I'm going to go back to Eclipse, and now I need to go up to the project folder. I'm going to go to properties for this project, and then from the properties box, there's a left side menu that's called Java build path. From this interface, we're going to
Can we run by that again?
Okay, one more time.
Yeah, please.
Okay, sorry, Tom, moving too fast. You're going to go to your project menu, choose properties. From that interface, you will select Java build path. Now, when you're in this interface, you're going to notice there's 4 tabs at the top. We want to go to the library tab, and then we're going to go use this particular button called Add External Jars. So I'm going to click. That will evoke the system dialog here. I'm going to go to my downloads folder, find the connector file, click open. And now you can see that the MySQL connector is added to the project. But you need to hit this button here. You need to hit the apply button to make it real. So I'm doing that. I'm hitting apply. And then I don't know if you guys caught this, but in the left side here, it also has now a new entry for referenced libraries, which is the MySQL connector. So I'm going to click OK to close the dialog. And then I can go here and I can see the connector file. If this connector file is not present in your project, this is not happening. Nothing's going to connect. That piece must be there. It's the communication mechanism that we use to talk from our application to the remote database. All right.
Last question.
Ooh, mine's in.
Go ahead, Jay.
Oh, where would you find this in IntelliJ?
I can walk you through it because I just did it if you would like.
Okay,
Okay,
well,
so
can I have you guys just hang right there for just a second, though?
Sounds good.
Okay. Let's solve that issue as soon as I do the demo here, because we're just about done. All right. So the next step is really pretty simple, folks. You just hit the play button, and remember, VPN has to be connected. And then what will happen is you'll get your driver loaded message, database connected, and if it successfully talked to the database and returned a result, you will see, a return from the database. All right, so I'm going to pause right here. Now we're going to make sure that everybody's is working. Okay, so Sam, if you want to demonstrate, I'll stop sharing.
Please and thank you.
In fact, I'll stop sharing. There you go.
So, what did you click on, Ty, to load that driver?
You know what? Let me repeat that step. And actually, I thought I paused recording, but what I really paused was the screen share. And so what you have to do is go to Project,
Can you see
Properties.
your face? Oh, Sorry.
Yeah, I wonder like project settings, I think, or properties. I think it's properties.
All right, we were able to successfully here in class work through getting everybody connected and working, and I just want to make sure that you guys can see this complete code. I had to use the
you
Can
staff
you share your
screen
screen time?
Oh, you guys, here we do it again. All right, so this is all in the video, by the way. This will be very embarrassing on YouTube, I'm sure.
It's okay, it happens.
Yeah, right. And then thank you guys for having a good sense of humor about it. But as you see on my screen here, I had to use the staff table to connect and pull back some of this information. All of my students who followed my directions carefully on uploading the SQL script file were able to use student as intended, and it worked great. But as I mentioned to them just now, what we've really accomplished is the fact that we've written an application on our local machines, tunneled through the internet to a database server on campus, pulled back information, and included it inside of our application on the screen here. Where we go next from here is now to accomplish the homework assignments, and we will get a start on it this week. And the real critical piece here is if I can establish a connection to the database to pull information back, I can also establish a connection to write information to that database and change it. And in fact, I can control the whole database through an application. Pretty powerful. All right, I'm going to terminate this video at this spot, and we will start a new video to work on the next exercise. So this video ends here.